Hello students, today we will do invertible functions. Now what are invertible functions? A function f(x) to y is defined to be invertible if there exists a function g y to x such that g of f equal to ix and f of g equal to iy. The function g is called the inverse of f and is denoted by f inverse. Now see here, if g is inverse of f, then you have noticed one thing, that domain will change into codomain and codomain will change into domain. You should remember one thing, that if a function f is invertible, then it will be 1 1 and on 2, and vice versa. That means if a function is 1 1 and on 2, then it will be invertible. Now see here, exercise 1.3. First question, let f one domain and codomain is given to you. G, there is another function g whose domain and codomain is given to you. Now is given by f 1 2 3 5 4 1. This is 1 has image 2, 3 has image 5 and 4 has image 1. Now and g is given by 1 3 2 3 and 5 1. You have to write down g of f. Now g of f, for f, what are the domains, elements of the domain? These are 1 3 and 4, so we will take 1 3 and 4. Now g of f1, first we are taking 1. Now g of f1 can be written as g of f1. Now what is f1? If you see the function f1, the image of 1 is 2. So in place of f1 we can write 2. g2, now see function g2, the image of 2 is 3. So this will be 3. Now again, second one is 3. In f, second element is 3. Now to g of f3, can written gf3. Now gf3, what is f3 here? f3, the image of 3 is 5. So we can write in place of f3, we can write 5. To g5. Now again in function g5, image of 5 is 1, so that will be 1. Again next element of f, that is 4, to g of f4, that is again gf4. Now f4 here is 1, so in place of f4 we can write 1. Now g1 is, image of 1 is 3, so that will be 3. Now what we are getting, g of f. Now in g of f, for 1 we are getting image as 3, for 3 image is 1, and for 4 image is 3. So we can write it as 1 has a image 3, so 1 3, 3 has image 1, 3 1, and last element is 3 is the image of 4, so it can be written as 4 3. Now similarly, if you want to find f of g, what we will do, we will find f of g. To f of g, to g has the domain 1 2 and 5. Element of domains of g are 1 2 and 5. So if you are finding f of g, we will take 1 2 and 5, and we will proceed as we have proceeded for g of f. Now question number 2, let f, g and h be the functions from real number to real number so that. Now there are 3 functions, f, g and h, and both of all of the 3 are from real to real. You have to show that f plus g of h equal to f o h plus g o h. This one was first one. Now see here, we are taking any element x of h, so that will be f plus g of h. This, in order to solve this, we have to take an element of h, and I am taking that as x. Now this can be written as f plus g of h x Now hx, we can replace this off by bracket. Now hx. Now f plus g hx. This you have read in class 11th, that under subtraction, multiplication or addition, the functions are distributive. That means we can say that this will be f of hx plus g of hx. Now this f of hx can be written as f of hx, and g of hx can be written g of hx. Now see here, if we eliminate this x, now what we are getting, f plus g of h equal to f of h plus g of h. And this was your proof. Similarly, there is another question given to you, f dot g of h. So that you have to put f of h dot g o h. You have to do it similarly as we have done in question number 2. This will be f of if you take x any element, then this will be f dot g of hx, and that will be f of hx into g of hx, and you can again eliminate x from it and find the answer. Now, third question, find g of f and f of g if fx is mod x and gx is mod 5x minus 2. Now we have to find g of f. So we are finding g of fx because variable here, the variable is x. So g of fx will be again written, we can replace this off by bracket. Now fx, what is the value of fx? Now fx is mod x. In place of fx we will take mod x. Now this will be g of mod x. Now g of mod x, now here gx is mod 5x minus 2. That means for x, this one is mod 5x plus 2. So for mod x, what will happen? We will replace the x by mod x. Now here, if we replace x by mod x, this will be 5. In place of x, we have to write mod x minus 2. Now, again, if we are finding f of gx, so this will be f of gx. Now, f, what is gx? Gx here is 5x minus 2. So in place of gx, we will take 5x minus 2, and mod is also here. So 5x mod of 5x minus 2. Now, mod of 5x minus 2. So f mod of 5x minus 2. So here fx is mod of x. In place of x, we have taken here mod x. So here also, in place of this one, we will take mod of this one. In place of x, we will write this whole function. So what will happen? The mod here, we have taken the mod, and inside the mod we will write the value of x, and that was mod 5x minus 2. Now second part of it, fx equal to 8x cube and gx equal to x raised to power 1 by 3. Now we have to find f of gx. So that will be f gx. Now gx is x raised to power 1 by 3. In place of gx, we have taken x raised to power 1 by 3. Now f of x raised to power 1 by 3. So here fx is 8x cube. Now always keep in mind, this value will come in place of x. Now in f x, so x here it is x cube. So in place of x, we have written here x cube. In place of x raised to power 1, in place of x, we will take this x raised to power 1 by 3. So this will be 8 x raised to power 1 by 3 cube. 3 will cancel out. That will give us 8x. We have to replace only x. Now, in second part, we are finding g of fx. So g of fx, what is fx here? Fx is 8x cube. So in place of fx, we will take 8x cube. Now, g of 8x cube, gx was x raised to power 1 by 3. So we will replace this x by 8x cube. In place of x, we will write 8x cube. 8x cube, and here power of x will be 1 by 3. The power will be 1 by 3. Now 8 means 2 cube, and 2 cube into 1 by 3 will be 2, and x cube into 1 by 3 will be x. So this is g of fx. Now here is a question. Fx is equal to 4x plus 3 upon 6x minus 4. X doesn't belong to 2 upon 3, so that f of fx equal to x for all x not equal to 2 by 3. What is the inverse of f? Now, this is function 4x plus 3 upon this is given in order to define this one. Now suppose we take x 2 by 3, so this will give us 6, denominator of this will be, and 3 2 just 6, that will be 4 by 4. 4 minus 4, and that will be 0. The denominator will be 0, and any number upon 0 is not defined. Therefore, he has given here x not belong to 2 upon 3. That the value of x cannot be 2 by 3. Now, first of all, you have to prove that f of fx equal to x. Now, for that, f of fx I have written here. Now, this will be fx. What is fx? Fx is 4x here. 4x plus 3 upon 6x minus 4. So, we will take this one, 4x plus 3 upon 6x minus 4. Now, this is f of this one. Now, that means here it is f of x. In place of x, we will take this whole value. Now, here it is 4 into x. What we will write? We will write 4 into x. And what is x? 4x plus 3 upon 6x minus 4. And then there is plus 3. Again, in denominator 6x, it is 6x. So 6, and in place of x, we will again write this one, or minus 4. Now, this will give us, ठीक है बेटा, ये हमेशा ध्यान रखना कि x, हम कोई भी क्वेश्चन है, हम उसमें x को रिप्लेस करेंगे इस वैल्यू से. नो, आफ्टर इसको सॉल्व कीजिए. आफ्टर सॉल्विंग दिस वी विल गेट f of f as x, and this is your answer. Now, after this, you have to also, you have to also find the inverse of f. Now, how will you find the inverse of f? Now, always keep in mind, whenever you have to find an inverse, you will solve it in 2 steps. Now, step 1 is you will take fx as y. So I am taking y equal to fx. Now, after put the value of fx here, and that was given to you. Value of fx was 4x plus 3 upon 6x minus 4. We have taken it as y equal to 4x plus 3 6x minus, in place of fx we have taken the value of fx. Now, after putting the value of fx, we will find out the value of x in terms of y. Now, we have solved it here, and we have obtained the value of x in terms of y. Now, this x, we will take this x as another function, and here I have taken the value of x as a function gy. ठीक है, तो here what we have obtained, we have obtained here the value of x, and this x I have taken as gy, because the function is in here, the right hand side is in the form of y, therefore I am taking it as a function gy. In place of x I have taken gy. Now, this one is gy. Now, after this, see here, now this one was our first step. We will take fx as y, and then we will find out the value of x in terms of y and take it as another function as gy. After that, in order to prove whether it is invertible, whether this gy function is inverse of fx that was given to us or not, for that we have to find f of gy and g of fx. So first I am finding out f of gy. Here I have written the function fx. Now, f of gy. So f of gy will be, what is the value of gy? This one is the value of gy that I have taken here. Now, in place of gy. Now, f of this one. So function fx was this one. In place of x, we will take 4y plus 3 upon 6y minus 4. In place of x, I have written this value. So this was 4x plus 3. So we will write 4. In place of x, we will take 4y plus 3 upon 6y minus 4 from here. And then it is plus 3 upon 6x. Again, in place of x, we will write down 4y plus 3 upon 6y minus 4 minus 4. Now, solve this. after solving this, we are getting its value as y. This can also be written as iy. Now after that we will find out g of fx. Now g of fx, similarly we will proceed as we have proceeded in f of gy. Here we will proceed like that also, and we will find out the value of g of fx, and that will be x. ये पूरा सॉल्व करना आपको, and that will be x, and x can be written as ix. So what have we seen here? We are getting f of gy as iy and g of fx as ix. That means this function g is inverse of the function g is inverse of f. So we can write, so gy, that was 4y plus 3 upon 6x minus 4, is inverse of fx, or we can write f inverse is equal to gy. Now here in your question number 9, he is saying that consider f r positive to minus 5 to infinity given by fx equal to 9x square plus 6x minus 5, so that f is invertible with f inverse y equal to this one. You have to prove that n inverse y is, value of n in f inverse y is this one. Now for the, what is r plus? R plus means all the positive real numbers. Now see here solution of this will be solution. Now for this, what we will do, we will first of all take this fx as 9x square plus 6x minus 5. Now we will solve this and make it a perfect square. This question is very important. Now see here, 9x square plus 3 is 6x minus 5. Now 9x square, this is the square of 3x. Now plus, now second element, now if we take a plus b whole square, this will be a square plus 2ab plus b square. So a square, this one is 3x square, then 2ab, to 2a was 3x and b, this will be 2 3 just 6x, and this is 6x. So b we can take it as 1. So this will be 2 3 just 6x into 1 will be 6x. Now plus square of 1. Now the minus 5 was here and minus 1 square. You have done it in class 10th, how to make a perfect square. Now this will be 3x plus 1 whole square minus 5 minus 1, and this will give us 3x plus 1 whole square minus 6. Now if the function is in the form of ax square plus bx plus c, then first of all you have to convert it into a perfect square. Now see here, now we will take, on taking, now we will proceed as we in the same way as we have done in the previous questions. Now on taking this fx as y, we will get y equal to 3x plus 1 whole square minus 6, and from this we will find the value of x. Now this will be 3x plus 1 whole square will be equal to y plus 6, and this will give us 3x plus 1 equal to under root y plus 6. Now 3x will be equal to under root y plus 6 minus 1. I am writing it in bracket to avoid the confusion. Now x will be under root y plus 6 minus 1 upon 3. Now after this we will take another function. Let us define a function g. Now here the range, or you can say the set of codomain was minus 5 to infinity, and that will become the domain. So minus 5 to infinity, and domain was real positive number. that will become range. If G is the inverse, so that will be range by G y equal to under root y plus 6 minus 1 upon 3. This x we have taken as gy. Now after this, the gy will be the inverse of fx, the function fx, the function given to us if f of gy is y and g of fx is x. Now f of gy, what will be f of gy? This will be f g y, that equal to, what was gy? Gy was this one, so f and gy was root of y plus 6 minus 1 upon 3. Now f of this one, now what was f? Function f was fx was 3x plus 1 square minus 6. Now don't put the value here, it will become difficult, so we will put the value here in 3x plus 1 square after making it a, what we have got after making it a perfect square. Now this will be what was it? It was 3x plus 1. This is 3, and in place of x we will take root y plus 6 minus 1 upon 3, then 3x, then plus 1 whole square minus 6. Here keep in mind, you have to take this under root y plus 6 minus 1 upon 3 inside the bracket, because it is value of x, and x is, here we are multiplying it by 3 only, so here we will multiply the value of x by 3, and then plus 1 will be written separate. Now here 3 will cancel out, and we will get under root y plus 6 minus 1, and this outside was plus 1 square minus 6. Again 1 will cancel out, and what will be square of root y plus 6? That will be y plus 6, and here it is minus 6. This is equal to y, and you can write it as I y. Now we have already obtained f of gx. Now we will find out g of fx. Now g of fx, what will be g of fx? This will be g of fx. Now g of fx, what is fx here? Fx is 3x plus 1 whole square minus 6. This I have written from the previous page. Now this equal to g of 3x plus 1 square minus 6. Now gy, what is gy as? That is root y plus 6. So that will be root y, and in place of y we will write 3x plus 1 square minus 6, and then there is y plus 6 inside the root, and minus 1 is outside it upon 3. Here minus 1 is outside upon 3. Now this 6 will cancel out. This will be under root of 3x plus 1 whole square will be 3x plus 1 and minus 1 upon 3. 1 will cancel out, and this will 3x upon 3 will be x, that equal to ix. That can be written as ix. Now here what we have done, first of all we have converted this function fx in form of perfect square. After that, in order to find the inverse, as we have done in previous questions, we are taking fx as y, and then find the value of x in terms of y, and we will take this x as another function. The domain of x, now here the domain of x will change into range, and range will change into domain. Here I have changed it, and I have taken it at another function as g, and this gy will be the value of x which we have obtained earlier. Now after this we will find out f of gy and g of fx. Now if we are getting f of gy as iy and g of fx as ix, then gy is the inverse of fx. Now as f of gy equal to iy and g of fx equal to ix, so inverse of f function fx is gy, and that was under root y plus 6 minus 1 upon 3, and this is proved.